Hey folks, here's 2011 number 4. Gives us a function. This is the function f. It says it's a continuous function. It is continuous. You can tell it's not differentiable there. It's got a corner from -4 to 3. The graph of f consists of 2 quarter circles and 1 line segment. So this is a quarter of a circle, this is a quarter of a circle, and then a line segment. G of x is 2x plus the integral from 0 to x of f of t dt. Find g of -3. Well, g of -3, so I'm going to write this down. First of all, we have g of x is going to be important to me is 2x plus the integral 0 to x of f of t dt. So it says find g of -3. Well, that's going to be 2 times -3 plus the integral from 0 to -3 of f of t dt. Now you can tell my bounds are mixed up here. So I'm going to have a -6 minus -3 to 0 f of t dt. So I want to look at the area from -3 to 0. Well, you can tell it's a quarter of a circle. And so the area of the circle is pi r squared. So -6 minus pi r squared. And then it's a fourth of it, so over 4. And what is your radius of that circle in this situation? 1, 2, 3. Your radius is 3. So -6 minus 9 pi over 4. -6 minus 9 pi over 4. And that's what g of -3 is. It also says in the situation that we should find g prime of x and evaluate g prime -3. So g prime of x, that's the derivative. The derivative of 2x is in fact 2. And then the derivative of this is plus f of x. Okay, so that's my derivative. Okay, now g prime of -3, that's going to be 2 plus, now this is where it gets a little bit challenging here, okay? We just type in that -3, and as you look at it, -3 has a value of 0 because that's f. So what's the value of f at -3? It is 0. So it equals 2 plus 0, which is just 2. Okay, so looks really complicated as we start out here. It turns out it's not too bad. B ends up looking really complicated as well. Turns out it's pretty straightforward, but determine the x-coordinate of the point at which G has an absolute minimum. Determine the x-coordinate on the point at which G has an absolute maximum, I guess a minimum, on the interval -4 to 3. So absolute max consider where G prime changes positive to negative. Okay? And G prime, remember, we already located that 2 plus f of x. So I want you to think about that. This is f. If we add 2 to this, the whole thing shifts up 2 units. If the whole thing shifts up 2 units, that means that this part's going to be above the x-axis. And that means that this is going to move up as well. You can see right now it crosses here at 3 halves. If I move this up 2 units, 1 unit, 2 unit, then it's going to end up crossing right there at 5 halves. So if we shift that whole graph up, because that's the derivative, it's 2 plus f of x. So if you shift everything up 2, it's going to change from positive to negative right here at 5 halves. that happens at 5/2. Part C, find all values of x on the interval -4 to 3 for which the graph of g has a point of inflection. G has a point of inflection. So we want to look for where G double prime changes sign. Okay, well, G double prime, G prime is equal to 2 plus f of x. So G double prime is equal to f prime of x. So we want to look for where f prime of x changes sign. If you look, this is f prime would be positive, 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 negative. So it changes sign right there at x equals 0. F prime of x changes sign from positive to negative at x equals 0. Inflection at x equals 0. That's what we have. And then finally D. Find the average rate of change of f. So the average rate of change is just the slope of f over the interval -4 to 3. -4 to 3. So you can see it's a negative rate of change you get from there to there. We just use slope. So we're going to find that. So we're going to do f of 3 minus f of -4 over 3 minus -4. And I get f of 3 is -3 minus -1. F of -4 is -1 over 7. And so we get, add that, so we get -2 over 7. Now it says that there's no point C on there for which the derivative is equal to average rate of change. So if you look here on our graph, do we ever have a slope of -2 over 7? So here it's positive, so we don't have a slope of -2 over 7. And then all of a sudden we get to here, and it looks like the slope is, let's see, 1, 2, 3, and over 1.5. So 3, so 6. Let's see, so that'll be 1, 2, 3, rise. So we would rise 6, and we would run 3. So that's a slope of -2. So this is a slope of -2 right here. So we go positive, 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 and also we have a slope of -2. What says never is there a slope of -2/7. Explain why the statement does not contradict the mean value theorem. Mean value theorem says that if you have a slope of -2/7, there's got to be somewhere else where the graph is a slope of -2/7 if the graph is both continuous, which it is, and differentiable, and it's not differentiable at 0. F is not differentiable at x equals 0. And that's why it doesn't contradict. Okay? Yeah, not a lot of questions like this stuff. I don't know what they're going to give you guys, but this does come up. This is a good example of some more things. You guys are almost there. Just a few left. Good job.